so looking at rectangles, a rectangle is a parallelogram. And so if you remember that yellow paper I gave you at the beginning of the unit, if you look at the tree on there, you have quadrilateral at the top. That's the funny shaped one. And then the types of quadrilaterals are parallelogram, trapezoid, kite. And then types of parallelograms, one of them is a rectangle. And on the back, there's space to write the characteristics of each shape. All right, so a rectangle is a parallelogram. So all of the qualities or properties of parallelograms apply to rectangles. So opposite sides are parallel. So we have this one is parallel to this one. This one is parallel to this one. Opposite angles are congruent. So T is congruent to R. U is congruent to S. Opposite sides are congruent. So the left side is congruent to the right side. The top is congruent to the bottom. Consecutive angles are supplementary. So on any side of the parallelogram, the two consecutive angles, one angle immediately following the other, add up to be 180 degrees. And it doesn't matter which part you look at. It could be the top, it could be the right, or it could be on the bottom. Those angles add up to 180 degrees. All right, and then diagonals bisect each other. I already did one line, two line. Okay. Running out of lines, so I guess it'd be 3 lines and 4 lines. All right, so that's for a parallelogram. Today, if we make it specifically a rectangle, then all 4 angles are right angles. So not only are the opposite angles congruent, but all 4 angles are congruent. So I'm going to change those marks to make it 90 degrees. Put the little box in each corner. Because all 4 angles are congruent and 90 degrees. And it's kind of in the name, right? A rectangle, angle. So it's a parallelogram with congruent angles. So if you take a 4-sided figure that's 360 degrees and you divide by 4 to get 4 angles, then each angle is going to be 90 degrees. So that's your first characteristic that is specific to a rectangle. And then the other is that diagonals are congruent. So now all of these pieces are going to be the same. So it is still bisected, but it's also the same length as the other diagonal. The diagonals are the same length. Okay? All right, so that's the characteristics we're using for rectangles. So we're looking at the first example. And on yours, I printed it before I copied and pasted all these rectangles, so you can just sketch them in. All right, so quadrilateral RUTS, which is the one on the top of the paper, is a rectangle. It says if US is 6x plus 3. So that line is 6x plus 3. And RT is 7x minus 2. All right, find the value of x. Okay, so what we can see here, with the property of rectangles that we're going to use here is that the diagonals are congruent. So actually you can still see it on the top of the screen, that bullet point. Diagonals are congruent, so that means they're equal to each other. So it's saying that US is congruent to RT. So I can fill in the values. 6x plus 3 is equal to 7x minus 2. And this says to solve or find x, so we're going to solve for x. To do that, we're going to get the x's to one side by subtracting 6x. So 3 equals x minus 2. And then I can get x by itself by adding 2 to both sides. And 5 equals x. So that's x. All right. So example 2 says quadrilateral RUTS is a rectangle. If the measure of angle STR is 8x plus 3, so we need to find that. STR, so you start at S, go to T, go down to R. So make sure you trace in order of the letters that it tells you so you know exactly which angle you're talking about. And then the measure of UTR gives us that also. Here's U, there's T, and then R. All right, so now I know I'm talking about the other part of that corner. And it says to find the measure of STR. So that's what I need to solve for. The green one. Since together, the green angle and the yellow angle make up a corner of a rectangle, and I know all of the corners of the rectangle are 90 degrees, I could say that angle STR plus, let's use purple for this one, angle UTR is going to equal 90 degrees because it's a rectangle. And then I can fill in the values that I have for them. 8x plus 3 plus 16x minus 9 equals 90 degrees. And now that I have an equation, the steps used in algebra to solve an equation is to combine your x's, and then combine your non-x's, and get x by itself. So that's what I'm going to do. Combine like terms. 8x plus 16x gives me 24x. And then positive 3 minus 9 is going to give me negative 6. And that equals 90. So I just combined my like terms. And now I'm going to start solving. So add 6 to get x by, work on getting x by itself. And 24x equals 96. Then I divide it by 24. And x equals 4. All right, but this problem didn't say to find x, did it? This problem said find the measure of STR. Okay, well I can do that. STR is the one I have in green. So angle STR is 8x plus 3. So 8, I'm going to leave a blank for x because I want to fill that in, plus 3. And then I found x. X is 4. So I'm going to take x is 4 and I'm going to plug it into that blank. Instead of putting x, I'm putting 4. So the measure of angle STR is going to be 8 times 4, which is 32, plus 3. So it is going to be 35 degrees. So the measure of the angle STR is 35 degrees. That's what that little m in front of the angle stands for, by the way, is measure. the measure of angle STR. All right, so the first three examples on this, the three on this side of the page, are pretty quick and easy. I just again, I copied and pasted the rectangle for all the problems, so I'd have a fresh one each time. You can sketch it if you want to follow along. It says if AE is 36, so I need to identify where that is. I'm going to make it green. So AE, it's right there, that's 36. And CE is 2x minus 4. All right. So on this one, I don't even need to know that it's a rectangle. Just knowing that it's a parallelogram is enough information, because rectangles and parallelograms have some of the same characteristics. Their diagonals bisect each other. Those two pieces together make up a diagonal. So that means I could say that AE equals CE, because it has been bisected or cut exactly in half. So then 36 equals 2x minus 4. So to solve this problem, I just need to use algebra. So I add 4 to both sides, and I get 40 equals 2x. And then when I divide by 2, I find out that x equals 20. And since it just said to find x, I'm done. Okay. So again, that's really just a parallelogram problem, but it still applies to rectangles. The next one, I have BE is 6y plus 2. There's BE. Then it says that CE is 4y plus 6. That's CE. And it says to find y. All right, so this problem, if it just said it was a parallelogram, I wouldn't be able to solve it based on just this information. But it does say that it is a rectangle. And so the property of rectangles, it says that the diagonals are congruent, means if they're congruent and they're bisected, then all of the sections are congruent. So again, I just set it up as the pieces are congruent. So BE is congruent to CE, which means I can say that 6y plus 2 equals 4y plus 6. And then I'm going to subtract the 4y to get my y's together. So 2y plus 2 equals 6. So I'm going to subtract 2. And I get, bring it up here, 2y equals 4. And the last step, I divide it by 2. So y equals 2. All right, so that is a specific to rectangles problem. All of the bisected pieces are congruent in a rectangle. So you really need to fill out that yellow paper, because there's going to be a lot of properties of quadrilaterals that you need to know for the test. And I'm letting you have a paper that tells you all of them. All you have to do is write them down and have it with you. All right, so BC is 24. AD is 5y minus 1. This is an easy one, right? That's a property of a parallelogram. Opposite sides are congruent. So that means, again, they're equal. So BC equals AD, so 24 equals 5y minus 1. So here I'm going to add 1. 25 equals 5y. Divide by 5. And y equals 5. And it says find y, so that is it. So again, that was a parallelograms problem, but it applies to rectangles. All parallelogram characteristics apply to rectangles. On the back, I have some trickier ones. It's still the same figure, rectangle ABCD. And you should always sketch whatever figure you're working with when you're working out the problem. When you don't, it makes it a lot harder. All right, so the measure of BEA is 62 degrees. So B to E to A. This one is a tricky one. That angle is 62 degrees. So I'm talking about this angle right here. And I'm going to go ahead and fill it in with a 62. Find the measure of BAC. All right, so where's BAC? BAC. That is this angle. I'm going to do this differently. All right, so how can we find out what that orange one is if all it was given is that this is a rectangle and the blue one is 62 degrees? This one's pretty tricky. Kind of have to think outside the box on this one, which is why it's an example. What if you look at this familiar shape? It is a triangle, yes. And a property of rectangles. One of the properties of rectangles is that all of these are the same, right? So now if I look at the triangle, and I have a triangle that has two sides congruent, it's an isosceles triangle, right? And if the two sides are congruent, what does that tell you about angles?
That means that the bottom two angles are congruent.
The two of the angles are congruent, so the base angles are congruent. And you're given the vertex angle is 62. So if you start with the fact that triangles have 180 degrees, so degrees in a triangle, and you subtract the 62, it's blue, the 62 degrees, that is angle BEA, then that gives you 118 degrees. All right, so now I have 118 degrees left in the triangle, and I have two angles that are the same. So I'm going to divide by 2 so that they're equal. All right, and then 118 divided by 2 gives me 59 degrees. So that tells me that both of these angles are 59 degrees. So that is the measure of BAC is 59 degrees. So sometimes, when dealing with rectangles, you'll be asked about isosceles triangles. Okay? Number 5. The measure of AED is 12x. Okay, so AED Alright, so I'm talking about that angle, and it is 12x. Alright, and BEC, B to E to C, this one is 10x plus 20. Find the measure of AED. So I'm asked for the green one. How can I solve this problem? What is the relationship with those angles? They are. These are vertical angles. So this is something we've been talking about all year. Vertical angles are congruent. So vertical angles are congruent. That means that 12x equals 10x plus 20. So that should be a familiar one to look at when you have the X shape. The ones across from each other are vertical angles, so they are congruent. And then we're just solving it. So I'm going to subtract the 10x. So 2x equals 20. And then divide it by 2. So x equals 10. Oh, but it didn't, never mind. X equals 10. But this one didn't say what is x. It says the measure of AED. So the measure of angle AED is 12x. So it's 12x. Anytime I'm solving for x and I know what x is, I leave a blank set of parentheses and then I plug in the value that I have. So this 10 is going to come up here and go in the blank. So this is 120. So the measure of angle AED equals 120 degrees. So you do have to make sure you're solving for what the problem says to solve for, as always. Is it asking for x, or is it asking for an angle, or is it asking for a side length? What is it asking for? All right, next one. If BD is 8y minus 4, okay, and AC is 7y plus 3, find BD. What is the relationship of the two diagonals of a rectangle?
They bisect each other.
Yes, the two diagonals of, well, yeah, they bisect each other, but yeah. Bisecting doesn't really help us solve this problem. It is true. The fact that they are congruent helps us solve this problem. Because it's a rectangle, we can say that BD is congruent to AC. So plug in for AC, 7y plus 3. Congruent is going to become an equal sign. BD plus is 8y minus 4. So BD is congruent to AC, so 8y minus 4 equals 7y plus 3. So I subtract 7y. Y minus 4 now equals 3. So add 4, and y equals 7. So I found out what y is, but I need to find BD. And BD equals 8y minus 4. So I take y is 7 and plug it in right there. 8 times 7 is 56. 56 minus 4 gives me 52. So BD is 52 units. We don't know what this is measured in, but it's a length. All right, this last one is a little tricky. All right, I'm going to start by just labeling the picture. If AB equals 6y. All right, so here is AB. And that is 6y. And then it says BC is 8y. So B to C. And that is 8y. And then it says to find BD in terms of what? Well, BD. And then it also says in terms of y. Whenever you see in terms of y, that means you're not actually solving, that y is a part of your answer. You won't see that very often, but it actually makes it a little bit easier. It means y is in the answer. So you're not solving for an actual number value. All right, so looking at the picture, what can I do with that? I have two sides of a rectangle, and I have a diagonal. What are the properties of rectangles?
They have 490 angles.
What'd you say?
Two pairs of parallel.
It's not the sides that are equal. What is it equal?
Yeah, just what, I mean, yeah.
The diagonals are equal.
They're very equal, right?
Well, the diagonals are
By
equal,
sifting it,
and the angles are all 90 degrees. So those are the two properties of rectangles. They're special to rectangles. So all of the corners are 90 degrees. And if the diagonals are congruent, then BD is the same as AC, right?
So they're equal.
So what if in the picture, instead of solving for BD, what if I solve for AC? And I made it go this way. Does that look more helpful?
See, yes.
It does, right?
It's very helpful.
It's very helpful, right? Because now
Yeah.
I have a right triangle. So I can set this up using the good old Pythagorean theorem,
Oh.
everybody's favorite. Right? So C squared, well, I'm going to A squared plus B squared equals C squared. So it doesn't really matter which leg I call A and which leg I call B. So I'm going to go ahead and say that A is the green one. And I'm going to call B the one I wrote, the yellow side, which I wrote in red. And then C is my blue one. And then I'm going to, instead of using the letters A, B, and C, I'm going to fill in what I have from the problem. So I'm going to do parentheses squared plus parentheses squared equals, well, equals C squared. Yeah. I'll do parentheses squared. All right, so A, I said, is going to be the green side, so that's 6y. And I said that B was going to be the yellow side, and so that's 8y. And then the blue is what I'm solving for, so that's AC or BD, it doesn't matter, but I guess to match the picture, I'm going to say AC. And that's what I'm solving for. I feel like that's probably close enough, but just to go for an answer for me, I'm okay with that as an answer. It's in terms of y. But I'm going to go ahead and solve it in terms of y. So 6y squared, you square the 6 and you square the y. So that's 36y squared. Plus 8y squared is going to be 64y squared. Yeah, y squared. And that's going to equal, well, that's what I'm looking for, is AC. But it's going to equal AC, the whole thing squared. So both the green and the red are like terms because they're both y squared. So 36y squared plus 64y squared, that's 100y squared. And that equals AC, whole thing squared. But I don't want just AC. I want to find out, I don't want AC squared. I want just AC. So to get rid of the squared on the AC, I'm going to take the square root of it. And if I do it on one side, I have to do it on the other side. So now I have the square root of 100 is 10. The square root of y squared is y. And that's going to equal AC. And AC also equals BD. So 10y. That's terms of y. I'll do it like this. So I've solved for AC. And so I can conclude, if AC equals 10y, that BD also equals 10y. I like it written that way better. I don't think you'll have one that complicated in your assignment, but it's good to see it.
Chinese Russian now.
Can I use it?